previously we have studied inverting, non-inverting and difference amplifier using op amp. Today we will see an amplifier which is made up of op amp, but it is bit complicated, at least apparently complicated, but once you understand it, then it is very easy. Okay. It is complicated because it is made up of not just one op amp, it is made up of 3 op amps. Okay. So, let me first tell you how it looks like. Okay. So, it is made up of 3 op amps, 1, 2 and 3. And this is a 2-stage amplifier. Okay. Let me just first write a few words before I draw this circuit. Number 1, this is a difference amplifier. What is a difference amplifier? A difference amplifier is an amplifier which takes the difference between 2 values, 2 voltages and amplify it. Okay. So, it is like this. So, if I draw it like a black box, so this is a difference amplifier, diff amp. It has 2 inputs, not one, V1 and V2, and the output, call it VO. This is some factor constant gain multiplied by V1 minus V2. This is how a difference amplifier behaves. So, this amplifier which we are making, this instrumentation amplifier, is also a difference amplifier. This is point number 1. Now, point number 2. This is a 2-stage amplifier. This is a 2-stage amplifier. What do I mean by a 2-stage amplifier? It is basically 2 amplifiers in series or in cascade like this. Okay. Stage 1. So, you give the input. From here you will have some constant multiplied by this input. This will go to stage 2, and from this we will have this k, call it k1, then we will have k2 times k1 times the input. This is equal to output. Okay. So, this is what a 2-stage amplifier is. So, you have one input which is amplified once and then amplified again. Now, let us come to this circuit. As I said, it is a 2-stage amplifier. So, let me draw 2 stages. This is going to be one stage, and this is going to be other stage. First stage will have 2 op amps, next stage will have 1 op amp. Now, the way to connect it, I will just tell you now how to do it. Later when I do more derivations, when we understand its function, then you will see you do not have to remember it. You can make it on your own. Right now, I will just tell you how to remember it. So, let us put plus minus signs, plus minus minus plus. From their output, you take a potential divider with 3 resistances, 1, 2 and 3. Join them, join the outputs. from here give a feedback, negative feedback. Okay, give a negative feedback. That means this potential will be fed back to the negative input. Similarly, here also you give the negative feedback. Okay, that's why I drew minus here, because I wanted to join it like this. Okay, feedback should be negative, should not be positive. So, okay, these two inputs are connected. Now, two more inputs are left, 1, 2. These two I will use as the two inputs of my overall amplifier. So, these two are going to be two inputs, call them VI1 input 1 and VI2 input 2. So, these are inputs. Okay. And this two will be two outputs from these two op amps. So, this you call VO1, V output 1 and this V output 2. So, this is the stage 1, which has two inputs, two outputs. Two inputs, two outputs. Okay, and this is a difference amplifier. So, the difference between the two inputs will be amplified, and that will get reflected in the difference between the two outputs. Okay. So, this is a two input two output amplifier. So, the difference of these two outputs, call it VO1 minus VO2, this is the difference between two outputs, will be equal to some factor, call it K1 multiplied by the difference between two inputs VI1 minus VI2. This is how it will work. Okay. This is stage 1, and stage 2, this will be just a normal difference amplifier which we have studied. This will be same as a normal difference amplifier with a single op amp difference amplifier. Okay. So, how does that look like? It looks like this: put minus plus, give negative feedback. So, you know this minus connected to output, N to output and plus P to ground, G, N O P G. Then we have two more resistances, and these two are going to be the input of this difference amplifier, and this is the output of difference amplifier. Okay. So, this is a two input, one output amplifier, normal difference amplifier. Okay. And you have to join these two, stage 1 and stage 2. How? Connect this output to this input and connect this output to this input, right. This is just a normal difference amplifier. And you know, in a normal difference amplifier, we should have these two resistances equal, call it R1 and R1. These two resistances equal R2 and R2. Let me give these resistances some name, call this R3. This also should be symmetric normally, you can call it R4. So, you call this also R4. This is how it looks like, the instrumentation amplifier. So, finally, then it is this which has 2 inputs, 1 output. This is the overall amplifier. Inside it we have 2 amplifiers, one is this, another is this. The first one is a 2 input 2 output, second one is a 2 input 1 output. Now how does these two stages work? Okay. So stage 1, let us do the analysis first quickly, less rigorously, and then I will do more rigorously. Now this potential is Vi1. If virtual sorting works, then this potential will also be Vi1. Okay. If virtual sorting works, then this potential, call it Va, this you can call Vb, then Va will be equal to Vi1. If virtual sorting works, let us assume it works for now. And similarly, for this op amp, Vb will be equal to Vi2. So this is same as Vi2, this is same as Vi1. Now no current can flow here, right? No current can flow here and no current can flow here, right? So the current can only flow in this branch like this. Okay. If a current starts from here, it will flow continuously like this and will stop, I mean will come up to this. No branching is possible here or here. Okay. So this current will be a common current continuously. So let us call this current as I. Okay. I is the current which starts from here and goes there. Nothing can come branch out from here or here. Okay. That is obvious, for op amp that is obvious. Okay. Therefore, how much is this current? Now we can write this current I will be equal to Vi1 minus Vi2 by R3. It has to be, from because this is Vi1, this is Vi2 divided by R3. And the same current is flowing here. So can we not then write this is also equal to VO1 minus VO2, VO1 minus VO2 divided by this total resistance, which is R4 plus R3 plus R4. Now from this, can we write VO1 minus VO2, this is equal to, so this is equal to this Vi1 minus Vi2 divided by R3, and let us multiply this here. So we will have R3 plus 2 R4, right. So this is the output, which is input multiplied by this quantity. This is for stage 1, okay, assuming virtual sorting works. Now, so this is, so here as we said that output will be proportional to the difference of input, difference of output proportional to difference of input. Yes, that is what we have here, and the derivation is simple. You just observe same current flows from here to here. Okay. So, and this potential difference between these two is same as the input difference, and this is the output difference. Okay. Simple. Now for stage 2, this is just a difference amplifier, and we have done the derivation for it in a lot detail. So, we will not do it again. So, this is just a difference amplifier. So, therefore, we can write directly that this voltage, okay, call it V O, final output. Now, V O will be how much? For a difference amplifier, this is R2 by R1 multiplied by the difference between these two voltages, this minus this, VO2 minus VO1, because VO2 is connected to the plus side, VO1 is connected to minus side. So, plus minus, okay. This is VO, and if so, then from this we can easily write this is equal to R2 by R1, and this is given here. So, let me write this multiplied by R3 plus 2 R4 by R3 from here, whole multiplied by Vi1 minus Vi2. This is output. So, what do we see? Output is proportional to the difference of the two inputs, just like it has to be for a difference amplifier. So, we say difference amplifier takes the difference of two quantities and amplifies it. This is same thing is happening, and the gain in this case, so gain is how much? Is this factor R2 by R1 multiplied by R3 plus 2 R4 by R3, right. So, the derivation is very simple. Okay. So, the derivation is very simple, and now once you know the derivation, you can now remember this circuit, because the second stage is just a difference amplifier which we have studied many times, and the first stage is like this, which has two inputs, take a potential divider, connect it between the two outputs, and from the middle point feed it back, negative feedback, here also negative feedback. Once you know the derivation, you can remember the circuit. Now, let me ask a more involved question, which is, here we have assumed the virtual sorting works. Okay. Does it really work? That is a more interesting question. So, the question now we are asking is, will virtual sorting really work or not? Okay. So, for this, we can get rid of the second stage, because second stage is a difference amplifier which you understand very well. The first stage is something new, where in the derivation we have assumed the virtual sorting without justification. Okay. So, let me get rid of this part. For clarity, okay. So, I will say that in an op amp, from its static characteristic, you just observe that the output of an op amp can take 3 different values. So, let us check whether these what happens if these voltages are increasing or decreasing and then how will the op amp behave. Okay. So, just note that for any op amp, if Vp is greater than Vn, then Vo output will increase towards plus V supply, and similarly if Vp is less than Vn, then Vo will decrease towards minus V supply. This is the rule of an op amp. Okay? If Vp is higher than Vn, then output will go towards positive V supply, it will try to go towards the saturation plus V saturation, and if Vp is lower, then output will go down to the negative V supply. Now, you see in this circuit what happens because of the negative feedback mainly. If at any moment say Vi is greater than Va, okay. So, let us say if Vi1 is greater than Va, okay, then this is higher than this, then what will happen? Output Vo1 will increase, then Vo1 will increase. Okay. Now, assuming that everything else in the circuit remains unchanged, okay, assuming that like this voltage is not changing, this voltage is not changing for simplicity, then what will happen? This is increasing, then this current I will increase, okay, then I will increase, okay, and if I is increasing, right, then so this point VO2, this potential is not changing, as assuming, okay, this is at a fixed value, this current is increased, so then this potential will increase, right, because this potential is same as this Va we know is same as VO2 plus I multiplied by R4 plus R3. This is the drop here. When I add this drop to this voltage, I get this voltage here. Okay. So, now if this I you see is increasing, this I is increasing, okay. VO2, this is constant assuming, okay. Then Va will also increase, right, and how long will it increase? It will increase until and unless Va reaches Vi1, okay. So, Va will, so VO1 will increase until Va becomes equal to Vi1, and then the op amp's output will take that particular value which had made this two equal, okay. And even if say if you change the output further, if you increase input further, if you increase it, this will cause the output to increase and it will make the Va also increase and get equated to Vi1. Similarly, if you decrease this, just think it on your own. If you decrease it, then this positive input is decreasing, and if it goes down below VA, then VO1 will come down. If VO1 comes down, then this current I comes down. If I comes down, then this potential also comes down. Okay? In this way, what happens, if you change VI1, op amp will change its output and will make as long as possible this VA equal to VI1 until this goes to saturation. Okay? So, virtual sorting works. This is because of this negative feedback. Okay? Similarly, in this op amp also, you do the analysis yourself. Okay? Say if Vi2 increases, and if it goes above Vb and Vi2 becomes greater than Vb, then what will happen? Then VO, so this is greater than this, so VO2 will increase, then VO2 will increase, assuming everything else now remains same. So, VO1 is same, so this is increasing, so current I will decrease. Okay? Then I will decrease, and if I decreases, so then this potential will go up, because Vb is same as VO1 minus I R4 plus R3. Now, I is decreasing, this let us assume this is constant, this is decreasing, so this will go up, this is going down, this is going up. So, then Vb will become same as Vi2 once again, and then the op amp will stay stably. Okay? So, this way once again the virtual sorting between these 2 points will work. But now, a note of caution is that if you by chance, by mistake, swap these plus minus symbols, okay, so mistake, if you by chance say swap this, you make it minus and make it plus. Okay? Then let us see what happens. Virtual sorting will not work anymore. Now, virtual sorting will not work. Why? Let us see. Say if Vi1 increases from Va slightly, okay? If ever Vi1 becomes slightly greater than Va, slightly, okay, then what will happen? VO1 will become negative, will try to go towards negative, because this is higher. Then VO1 will decrease, will go down towards minus V supply, right. So, this value is decreasing. Now, once again assuming everything else in the circuit is not changing for simplicity of analysis, if this is now going down, what will happen to this current? Therefore, I will decrease, assuming everything else like VO2 is unchanged. So, this is unchanged, this is decreasing. So, this current will decrease. Okay. Now, if this current is decreasing, then what can we write about VA? VA, which is same as VO2 plus I R3 plus R4. Now, I is going down, this we have assumed not changing. So, this will also go down. Okay. So, VA is going down, and therefore, the gap of VI1 minus VA will increase. Okay. Because VA was already less than VI1, and now VA is going down, VA is going down further. So, this gap will increase. Okay. And if this gap is increasing, then VO1 will go down further. Okay. So, VO1 will go further down, and this way a chain reaction will happen. This is going down, which will cause current I to go down, which will cause VA to go down, and if VA goes down, the gap between these two increases. So, VO1 will go down, and this way a chain reaction will happen, and finally, VO1 will finally reach the lowest possible value, which is minus V supply, saturation. Okay. So, output will go to saturation, and you see this gap, as we said in the chain reaction, continue to increase. Okay. So, this gap increased continuously in a chain reaction. So, there was no chance that this gap will be brought down to 0. So, virtual sorting in this case will not work. Similarly, if you swap these two terminals, if you make this plus, this minus, then for this op amp virtual sorting will not work, and then you cannot do this derivation, you cannot write these equations. Okay. So, this will no longer act as an amplifier like the way we were expecting. So, plus minus symbols, correct plus minus symbols is very essential, otherwise your circuit will not work, your answer will be wrong. Okay. And last thing that I will finish with one statement is that when you connect the inputs, okay, suppose you, okay, let me say it in a different slide. Okay. Suppose you have a battery which has a voltage, call it V in, small battery, and you want to say amplify this voltage, and then you possibly will measure it. Okay. So, what you will do, you can connect it like this. Okay. But also do not forget to connect, to create a common ground to this input. Okay. So, what is this ground? This ground means this is the same ground as this one here, or you actually have the power supplies. Let me also draw all these power supplies in a different color. So, all these will have their power supplies. Okay. Say like plus minus 12 volt. So, this is 12 volt, this is also 12 volt. So, this is connected to minus 12, this is connected to plus 12, this center point can be grounded, and this is the reference point 0 volt to which this terminal is also connected. Okay. For similarly, this you can connect here, this power supply you connect to the positive side like this. Okay. All negative sides you have to connect to the minus side. Here also this will go to the minus side like this. Okay. Although the diagram is ugly, but I think the idea is clear, I hope. And this ground this should be common. Do not leave it floating like this. Okay. Please do not leave it floating like this. Okay. This is how to use instrumentation amplifier. Thank you.